Okay, so there's a new lab for this week, and this will roll over into next week as well, I think. And you will be submitting this lab to me, and it'll be the last lab that you need to submit. We need to continue on with the slides, though. So the last day we finished off talking about services. I go back to here, yeah. And we said that there are four types of services, these here. This is definitely the one that we will use most regularly. We won't use either of these two. Uh, I will need to talk about the ingress service as well, but I'm actually going to skip over that today and move on to another area because we'll need this other area for this week's lab. So the area is that is volumes. You might remember volumes when we were talking about them during our discussion on Docker. So volumes was this idea of sort of attaching an external directory or file to a container. And clearly that's something that we would like to be able to do with pods as well. So, uh, notionally, anyway, the two kind of problems that we're trying to address here is number one, we know that when a pod crashes, if that pod happens to have been creating any data during its execution, then all of that data is lost when the pod is recreated. Okay, Kubernetes will recreate the pod for us, but it essentially creates a fresh copy of the pod, if you like. So we've lost any data that it might have created during its execution. The same actually applies if a node crashes, if there was any data created by any pods, I guess, then all of that data is lost when a node crashes as well. The second problem I'm seeing here is that if you want to share data across a group of pods, whether those pods be on the same node or running on different nodes. Uh, at the moment, anyway, we don't know how to do that. And the answer to solving these two problems is to have a volume that is essentially external to the cluster. Um, so, so a volume is a directory containing data that is accessible to a pod. Okay, that's a very kind of general uh, statement, I suppose, but now we are told here that there are three types of volumes. Now, one and two don't really solve our problems. That one and two are useful for debugging, but they don't solve the problem one and two at the top of the slide there. The one that we're really interested in is what is called persistent volume. Just for the sake of completeness, we have this kind of concept of what's called an empty dir volume in Kubernetes. And if you put data into this empty dir volume, the data is outside the container, but it's within the pod. Uh, so I'm not sure how useful it is, but it can be useful if I'm saying here, if you're just doing some sort of debugging or some sort of development work. Uh, the other type is host path. Now, in order for us to be able to use the host path volume, a host path volume is a volume that is contained within a particular node or it's managed by a node. And any pods running on that node can access that data. Uh, that's slightly more useful than DNP there, I guess, but where it falls down is if the node actually crashes, then you have lost any data in this host path volume. Uh, Certainly the best of the three is this thing called a persistent volume. And as I said, a persistent volume is actually exists outside of the cluster, but it's accessible by pods on any node within a cluster, provided, of course, that the node has the permissions to access it. So this third one is the one that we want to talk a little bit more about. Now, it's slightly, I wouldn't say it's overcomplicated, but it's not as straightforward. It's not just a case of let's create a persistent volume and attach it to a set of uh, pods. It doesn't actually work that straightforward. So when you want to use these persistent volumes, there are essentially three types of resources that are involved. There's this persistent volume resource. There's something called a persistent volume claim, second type of resource. And the third type of resource is a storage class. So each of these resources need to be created in order to use a persistent volume in order to allow a pod to use a persistent volume. So to distinguish between the three of them, the persistent volume is the actual kind of physical storage itself. So it's a piece of storage that has either been provisioned by the administrator or provisioned dynamically by you, the user, I guess. And these persistent volumes are created using YAML, using a YAML manifest file. Surprise, surprise, there's no surprise in that. These storage classes, resources, you can't really create those. They are created by the administrator and they are completely kind of dependent on what external storage is available to a cluster. I'm saying here that the storage class that kind of declares the types of storage devices that are available to pod manifest, if you like. So, for example, you might actually use some sort of cloud provider as your storage uh, platform. So maybe AWS Elastic Block Storage. You might have remembered mentioning Elastic Block Storage in last year's module. That would be one way of doing it. Another way, which is the way that we have access to on our Kubernetes cluster, is to have an external network file server available to our Kubernetes cluster. And an NFS server has been created for us, so we can use that. And there are other kind of other cloud provider approaches as well. So I'm saying here that a persistent volume specifies the storage class, as well as how much memory you need, what kind of access modes you want to make available on your persistent volume. These are all kind of specified in your manifest file, which we'll look at in a second. And so, so we've got these three resources: persistent volume claim, persistent volume, and storage class. I think the storage class is straightforward enough. The persistent volume, that's straightforward enough as well. That's the actual physical storage on a particular device, and the storage is of a particular size, and there is a particular access mode associated with the persistent volume. A persistent volume claim, then, and the focus is on the word claim. A persistent volume claim is a claim to a particular persistent volume. So I'm saying it's a declaration by a pod that it will require storage. So sort of like a pod says, pod will have a persistent volume claim for 50 megs of storage on the network file server storage medium, and there will only be certain, maybe only read access to that persistent volume. So it stakes a claim for that amount of storage, and then the Kubernetes cluster will find a persistent volume to match that claim, or otherwise it'll actually create it and kind of bind the persistent volume to the pod via the persistent volume claim. So I'm saying a persistent volume claim is bound, or it's bound to a persistent volume by matching the storage class, size, etc. The other kind of whatever the properties that the persistent volume claim is looking for, matches that up to an actual persistent volume. And then once it finds a match, then it binds one to the other. And the persistent volume claim is linked to a pod. And once it matches them up, sorry, once it matches them up, then it essentially mounts the persistent volume to a container. And we understand this concept of mounting volumes onto containers. So this kind of shows the relationship between our various resources. A pod or group of pods, they have a persistent volume claim for a certain amount of storage, and that persistent volume claim then is linked to an actual persistent volume. The only thing that's left out of the pictures here, what are the different access modes? And these are kind of specific to Kubernetes. So the persistent volume access modes are read, write, many. God, sorry about that. Read, write, many, which means that the volume can be mounted by many nodes. Okay, so it's cross node, if you like. It's cross node plus it's both read and write access. Read write once is where the persistent volume can only be mounted by or accessed by one node. And then there's the equivalent in read only, read many and read once. There's also this one here, which we don't use that often, which is it's only accessible, where you've got a persistent volume that's only accessible by one pod. So you couldn't share it across multiple pods. The ones that we use most often are read write many and perhaps read write once, but really read write many. It's either read write many or read many. That's kind of the best of everything, where you can have pods on different nodes that can access the same persistent volume. Because we know when we create a deployment creates a replica set. A replica set creates multiple pods, but for availability reasons, those pods are distributed across the various worker nodes. And if we want those pods to share some data, then they have to access the same persistent volume via a PVC. And then the access mode will determine whether they have both read and write or just read-only access. Okay, so that's kind of the big picture. If we go to what we actually do is we create a persistent volume claim. So if we look at, where do I have it? Oh yeah, here. So this is a manifest file for a persistent volume claim. Okay, the API version is v1. The kind, there's persistent volume claim. And okay, you can see down here at the bottom of the screen, when I checked my API resources script for persistent volume, then, okay, there are two types of resources. There's persistent volume and persistent volume claim. They both happen to have the same API version number. The shorthand for persistent volume claim is PVC. The shorthand for persistent volume is PV. And these are the full kind of uh, these are the kinds. So that's why up here I've got in my manifest file, the kind is persistent volume claim. Metadata, again, just the name is really the only piece of metadata that we are using here, but you could have other metadata if you wanted to. And the spec then is essentially kind of a spec for the nature of the persistent volume that you want to have associated with this claim. And so we're specifying an access mode of read-write many. Read-write many, yeah, sorry. And essentially in the resources part, we are specifying how much memory do we require, 50 megs. And what's my storage class? Now, where did I get NFS client from? Well, if you go, this will kind of vary. The storage classes varies from Kubernetes cluster to cluster. But if I do an OC get on storage class, oh yeah, we can't really use that storage class. This is the storage class that we can use, NFS client, which, as its name kind of suggests, there is a network file server external to our Kubernetes cluster that has been provisioned for us. Okay, and so in my storage class here, I have to use one of these storage classes in my manifest file. I don't really have permissions to use that one. So the only one I can use is this one. And so that's where this is coming from. So this is a claim. This looks like it's a claim for 50 megs of storage on the external network file server. And uh, any number of my worker nodes have read-write access to it. Now, if I apply this manifest file, what Kubernetes will do is it will, first of all, it will obviously create this resource. It will create a PVC resource for me. It will also create the actual persistent volume for me. So if I go OC apply, uh, 0.9, and if I now go OC get, PVC is just a shorthand for persistent volume claim. So what I'm getting here now is I have a persistent volume claim. The name of it is Mongo SVC, Mongo PVC, sorry, which was what I had up here in my metadata. Um, uh, bound means that it's actually, the claim is bound to an actual persistent volume. This is the persistent volume that it's bound to. So Kubernetes just created that persistent volume on the fly for me. It's 50 megs, that's fine. Read write X, as in read write many, actually. That's how you interpret that. The storage class is that. Um, we needn't worry about this stuff over here. So that looks good. I have an actual persistent volume, and it's linked to a persistent volume claim. Now, all I've got to do now is just create some pods that link themselves to this persistent volume claim, and those pods will now have access to this persistent volume. So, as you can gather from the name, I'm actually going to have a pod that's going to be running the Mongo database, which is a kind of classic example of where you might need an external volume mounted onto your container. So here's my manifest file for it's a deployment. Let's see, it's a deployment manifest, which we were familiar with. Metadata, the name is Mongo demo deploy. That's all right. Now, because it's a database, it would only make sense to have a replica set of one. Uh, okay, so we'll have to live with that. The rest then is kind of we're familiar with. So selectors, this is just specifying. This is saying that this deployment will only match up with pods that have the label app and the value Mongo demo. And then template is the template for the pods associated with this deployment. Metadata for my pods. Okay, I want the pods to have that. Let's see, that label. So obviously this here matches up with the selector up here. And the actual spec then for my pods. Now I'm using an image. It's not the kind of standard MongoDB image that you get up in Docker. There's a one that's kind of more recommended by Red Hat, which is the Bitnami MongoDB image. Okay, so that's fine. We'll use that. But it is getting the image from Docker Hub, but it's not the kind of standard Mongo server. It's a slight variation on it. The environment variables for the Bitnami Mongo are just slightly different from the environment variables for your for the standard Mongo, but most of them are obvious enough. So it looks like I'm setting a the administrator username of admin, administrator password of secret. That's all fairly fine. The port is 27017, which is standard for MongoDB. And this is the new part then, really. So here we're specifying what volumes we want to have mounted onto the container that's containing this image. Okay, so I'm giving the name of the volume. And this is the path name where I want the volume to be mounted to. So the path name is slightly different for the Bitnami Mongo image. This was the path name, if you remember over here. This was the path name where we mounted for the kind of standard Mongo image. But that's okay. So I want this volume to be mounted at this particular path in my Mongo container. So we now have to find out, well, what's this volume? What are the details of this volume? And that's what I have down here. Now I've commented out some stuff. So the volume name, that has to match the name that you're using up here. Sorry, no. Just going to collapse this. Okay, the volume name has to match the name that you have up here. And the volume type, I suppose, if you like, the volume type could be any one of the types that I mentioned on the slides. Remember I said there are three types of volumes: empty dir, host path, and persistent volume. So I was kind of playing around with them. So in this example, anyway, we are using a persistent volume claim uh, volume. Okay, and the the claim name, Mongo PVC, that has to match the claim that we've created for ourselves, which is here, Mongo PVC. Uh, and that already exists. So this claim has to exist before I can actually apply this manifest file. And it does. That's why we created it already. And the storage class is, sorry. Oh no, that's just it, sorry. The claim name. So it's simply, when I apply this manifest file now, the Kubernetes cluster will go looking for a persistent volume claim with that name, and having found it, which it does down here, it will mount that volume onto this particular path within my container image. But the volume is external to the Kubernetes cluster. And so uh, let's do that. Okay, forgot to look at this part. There, in a manifest file, I'm not sure if that actually, if you completed last week's lab, you'll know this. In a manifest file, you can put a deployment and a service in the same file. And I'm just doing it here for convenience rather than having the service in a separate file. But this is just the service for the deployment that I have up here. So there's nothing particularly new in the service manifest. Okay, so when I went to OC apply of that file, it created both the deployment and the manifest. And of course, it will have created the pods as well, or there's only one pod really for the deployment. So if I now go OC get pod, get my pods, then I have one, this MongoDB pod. And I guess if I went OC describe, and I want to describe pod, this guy. So you can see here there's stuff about that in the volume section. It's recording the fact that there is a persistent volume claim attached to the volumes for this particular pod, and all that kind of matches up. So the upshot of all of this now is if I um, what can I do now? I can go I can do port forwarding to this pod. Well, I'm doing it via the service actually, but I could do it via the pod directly. It doesn't really matter. Um, Let me just check that now again. So this is the service that's sitting in front of my Mongo pod. So if I do port forwarding to that service, and I am forwarding port 27017 on my local host to that port on the service. And we did say in the service manifest that where we got it. Yeah, we're taking port 27017 of the service that is going to be forwarded on to port 27017 in the pod. So that's all going to work for me. Now what I can do is if I open up my Mongo Compass client, which you might remember we used back when we were looking at Docker. And I want to connect, let's see. I want to connect to MongoDB uh, admin admin to the admin user whose password is secret and the domain name of my Mongo server is localhost. That's because I'm using port forwarding. So if I try to connect to localhost, that will go to the service in my cluster, and the service is forwarding on to the pod. So it will eventually hit my MongoDB pod if I try and connect from this using this connection string. And you've done all of that. Uh, well, you've done all of this when you were using a Docker container and you were using port forwarding in the Docker container, if you remember. It's a while back now, I guess, admittedly, but so this connection string is eventually going to connect to the actual pod. So we'll try and connect. Okay, and let's create so these are the standard kind of default databases that exist within a Mongo server. So these are the actual databases now that are contained within the Mongo server that's running inside in my pod. But what I want to do, let's suppose I create a new database for myself, and we'll call the database TMDB, and we'll have a collection called, let's say, movies. Okay, there it is there. Now, that database now is actually created on the persistent volume, which would mean that if I deliberately delete my pod, because the pod is part of a replica set, Kubernetes will recreate that pod. Uh, but because my database is kind of stored in this persistent volume, which is external to the pod, then the database will still exist. I guess that's the whole point, yeah? So I don't have to, but if I just disconnect and if I go back to here, and I'll just stop my port forwarding. If it allows me. And let's see, OC gets. Now, if I go OC delete pod, this one here, but of course, it's going to be recreated for me. It's a new pod now that I just see it's actually being, it's currently being created. If I do it again, it's now running. If I do my port forwarding again, and if I go back to my Compass client and I try and connect again, the TMDB database should still be there. And yeah, there it is, still there. And the movies collection is still there. Okay, so that looks as if it's working. If I disconnect again, go back to here, and stop my port forwarding. If I actually go into the manifest file and I'm going to change the type of volume to empty dir. Do I have time? I do, yeah. So if I change it to empty dir, an empty dir volume, that exists outside of the container, but within the pod. So that means when I delete my pod, any data is going to be lost essentially. So I'm going to comment out this bit here. And I should be able to apply all this again. So if I go OC apply, uh, see get pod, see describe. Uh, well, it's changed anyway. Sorry. Yeah, see, okay, so it's a different type of volume now. Now, what are the implications of that? Well, if I do my port forwarding it again, Go back and connect. Now, if I create my new database, so we're dealing with a completely new, we've changed the pod manifest file. So when I went to OC apply, I'm dealing with essentially with a new setup now. Um, so I create TMDB again, collection movies. Okay, so that looks good. That's there. But if I now delete the pod, and Kubernetes will recreate it automatically, because this database is part of this kind of empty dir volume, which is essentially a volume that has been just created within the pod, external to the container, but within the pod. And that means when I delete the pod, it's lost. So if I go back to here and stop my port forwarding, get my pods, delete that pod. Now it's going to be recreated for me. And it's recreated already. Do my port forwarding. Connect to it. I didn't disconnect, but that's okay. Can I just do a refresh? Yeah, so I just refreshed the connection, but you can see my TMDB database is gone. And that is because, hopefully it's clear now, that is because the type of volume that I was using, it only really existed within the pod. It wasn't external to the pod and it wasn't external to the cluster, which was the case with the persistent volume claim setup that we had. Okay, so in this week's lab, you will be creating, your persistent volume claim. You'll be kicking off an instance of the MongoDB um, server within a deployment. You'll also be creating a second deployment that's going to be communicating with your Mongo server. So you'll actually have a multi-pod kind of application. If I just quickly go over to the lab. Is it there? Yeah, see, this is what you're going to be creating. You're going to have a persistent volume claim. You're going to have a Mongo pod and a Mongo service. You're also going to have a Node Express pod that's running you might remember that Web API Express application. It's going to have its service. This pod is going to be communicating with that service, which means this pod is essentially trying to access or communicate with this pod here. It doesn't communicate with the pod directly, communicates via the service, which is the whole point of services. And we will use port forwarding on these pods actually in this case, or I think we actually use port forwarding on this service, which will allow us to view the data in our Mongo server Like I was using Mongo Compass, which is an external client. But here you're actually going to be using a client that's deployed as a pod. So you've got a multi-pod or a multi-deployment, I suppose, really set up here, which is going to be interesting for you. Okay, so tomorrow you will work through this lab, and I'll stay online tomorrow just to make sure you can work your way through it. This is going to be very important now for the end of semester exam. So it's important that you work your way through it and understand it. We can talk a little bit about it maybe next week after you've set it up for yourselves.
And
Okay.
is there, for the end of semester exam,
Hmm.
what kind of things will be on that exam? Will we
Yeah,
just be deploying
I'll
to
give
the
you some
customer?
det I'll give you some detail on that when we get close to it. But there's no need to be concerning yourself about it now, really. But I will give you some briefing on it when it gets closer. It'll probably happen in week 13, I'd say. I don't think I'll fit it into week 12, but I'll certainly will give you some briefing on that, well in advance of the actual exam. There's no point in talking about it now, really. I haven't actually set it, so I can't really talk
Okay.
about it. So, but even
It's
if
not
I,
like a multiple choice exam, is it? No.
no, 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 it will be very practical based. So
Okay.
you'll be writing, for example, manifest files, that kind of stuff.
Okay. Thanks.
Yeah. And you'll have complete access to uh, any of the labs that we've worked on, the PowerPoint slides. It's kind of open book in that sense.
Okay.
Right. So I'll touch base with you tomorrow over Slack. Thanks a lot.